All right, this is Math 2, Unit 6, Lesson 5, looking at proportions of triangles. Homework help for questions 1, 2, 6, 7, 10, 11, 14, 15, 18, 20, and 21. Not sure what your teachers assigned for you, so I'm going to run through several samples of these. Again, they're probably not the best explanations. Just kind of going to go through the steps I use to solve these here, and what I would do if I was kind of in your situation here. So, looking at what I have, first of all, the first ones are some simple proportions you're looking at and finding the corresponding parts. So I have CF, this line here, equal to something, and I'm comparing it to AC, that length, and AI, that length. So because I'm looking at basically these two lines and what they're doing, I have a CF here. So if this is my CF, then what's missing is going to be this portion right here, which is FI for number 1. When I look at number 2, I can tell that they're looking at A to B, so this part here. And then I see BC, so this part here, and then I can see something, and then an H and an I. So I'm looking at which parts they're missing. I have a match, 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 no match, which means they want me to put in this little box A, H, that box there, because that's the part that they didn't already note for me. And number 6, same idea. We have AC, which is this longer bit there, and then we have AI, which is this longer bit here. And on my other side, we have something, an X value, and we have an IJ. So here's my IJ. So when I look at what's missing on the other side, I'm missing the CD portion, which would go right in that square there. So just setting up that proportion to make the sides match. Looking for what part is missing within the equation there is the idea for those ones. Okay, here we go. To do these problems here, there are, again, 3 theorems you're looking at that are important to remember. Theorem number 63, or the side splitter theorem, recall that if you have 2 parallel lines, that the value of XR over the value RQ, so this to this, is going to be proportional to this is the idea. So when you look at a question like number 7, we can see that we're using the side splitter theorem. We're going to go ahead and set it up and say, all right, because this is a side splitter theorem of 2 parallel lines, I can set it up by simply saying that 4 over 6, so this to this, is equal to X plus 3 over 12 minus X. Alright, so again, the side splitter theorem, I have side to side is equal to side to side. Same order, same direction. So I went this one to that one, so I'm going to go this one to that one. So make sure you go the same order. So 4 to so bottom to top in this case is equal to bottom to top. All right, so just don't get them out of order. You'll get something totally different. To solve this here, I will cross multiply, and I end up with 4 times 12 minus x equals 6 times x plus 3. I will use the distributive property and then determine that I have 48 minus 4x equals 6x plus 18. Oops, I forgot my x right there. Sorry about that. So 48 minus 4x equals 6x plus 18. I will go ahead and add 4x to both sides. And if with a 10x on this side, and I'll go ahead and subtract 18 from this side and that side to end up equaling 30. So 30 equals 10x. Divide both sides by 10. And x equals 3 for number 7. And that's your idea, using the Theorem 63, the side splitter theorem. You will need to know these theorems when you get to your test at the end of the unit, so don't lose track of those. All right, looking at number 10, the next one on my list to do with you guys. Number 10 uses the angle bisector theorem. This is going to be Theorem 64, the angle bisector theorem. Remember the angle bisector theorem, the idea was we take a line, it bisects the angle, so I have 2 equal parts there, that CD, right, over DB, so my bottoms of the 2 things, are going to equal, right, this is like bottom number 1 and bottom number 2, are going to equal CA, side number 1, over BA, side number 2. So in the way it's set up in this case here, I have my bottoms to bottoms, bottom over bottom, over side over side. And the CD connects to the AB. This is the same triangle right there, and the same triangle right there. So same parts, same sides. So that's the angle bisector theorem. So I'm going to use that to set up number 10. When I set up number 10, looking at my angle bisector theorem as well, hard to see there, no? Okay, I'm going to take the bottom, 16, over the other bottom, x, and set it equal to the matching side, which is 20, over this matching side, which is 4. And now I can solve that proportion. If I wanted to reduce, first of all, I could. 20 over 4 is the same as 5 over 1. Now I have some nicer numbers to work with. 16 times 1 is 16, which equals 5 times x, which is 5x. I'm going to divide both sides by 5. I've determined that x equals 16 over 5. All right, I could turn that into a mixed number. 5 goes into 16 3 times, and so I have 3 with 1 left over and 3 1/5. The way your book solves it, they leave it as a proportion, so they want you to determine what is the value of 3 1/5. I could do division, I could do however you want to do it. 1/5 you might know is a 0.2. You might have to say, okay, 5 goes into 16, it goes in there 3 times, 15, 16 minus 15 is 1, add a decimal, and then put a 0 down here to bring it down. 5 goes into 10 2 times, so I have 3.2. So the book gives you your answer as a decimal form, 3.2 for the value of x. If you want it as a fraction, it's 3 1/5. If you left it as an improper, you'd have 16 over 5 for the value of x there. Probably go ahead and put in the decimal because later on you'll have to use that number sometimes to find other missing elements. So up to you how you want to solve it with fractions or decimals. It's kind of your call there. All right, looking at number 11. Number 11, we have sets of parallel lines, and we have some lines that intersect those at different points. This is the corollary to the side splitter theorem. So putting it up here for you real quick. What we said with the corollary to the side splitter theorem is that if we have these parallel lines, then different segments are going to be proportional. So AB, this little bit over the big bit BC, is going to be proportional to the little bit of this part, WX, over XY. That's the idea. So little bit to big bit is going to be equal to little bit to big bit. So when I look at number 11, to solve this one and set it up, I'm going to say this bit here, 20, over that bit there, 8, is going to be equal to this bit here. Well, I don't know this bit there. It says it's 35, and that's x. I do know the little bit is definitely x. This part I don't really know what it is. I just know that it is 35 minus x. That's all I can say about it. I know the whole thing is going to be 35, so this is going to be whatever's left when I take x away. So it sets up a little bit weird, but that's okay. Again, I could reduce this because I know that 4 goes into this 5 times and 4 goes into this 2 times before I cross multiply. And I end up with a 5x equals 2 times 35 minus x. I'm going to go ahead and use my distributive property on this side here to find out that 5x equals 70 minus 2x. I'm going to add 2x to both sides. So now I have 7x equals 70. I'll divide both sides by 7, and x is going to be equal to 10. Oops, and I lost you there. Sorry, I ran out of space. So it's moving on down. 7x equals 70 divided by 7, and x equals 10. All right, so that's number 11, using the corollary to the side splitter theorem. The last one on this page I want to look at is number 14. And again, we have the angle bisector theorem, which is theorem 64. Okay, same idea. Okay, I can use the bottom here, which is x, over this side here. Again, I don't know what that is, but I know that the whole thing is 18. So this portion is going to be 18 minus the little bit x. Then I'll get my sides matched up. If I use this x side, I'll use this as my top 10. And for this one, I go this way and I have 15. Once again, I can reduce. 5 goes into there 2 times. 5 goes in here 3 times before I cross multiply. 3 times x is 3x, which is going to equal 2 times 18 minus x. Distributive property. 3x equals 2 times 18 is 36. 2 times a negative x is a negative 2x. So I add 2x to both sides, add 2x to both sides, and I end up with 5x equals 36. How are we doing so far? You're like, oh no, another crazy number? Yeah, it looks that way, doesn't it? It is indeed. 5x equals 36. That's okay, and that's why I'm doing this one, just to help you know that you're on the right track. That is right. I'm going to divide both sides by 5, and so I'm left with then x equals 36 divided by 5. So I'll just use this space right here to do that real quick. So here's 5 going into 36. 5 goes into 36 7 times. For 35, I get 1 left over. And I got a decimal, bring down a 0. 5 goes into 10 2 times, so my answer is 7.2 as a decimal. So it's a little weird, but that's why I wanted to go ahead and solve that out and work it out for you, so you know you're on the right track. The answer does come out strange. You do get a fraction, 36 over 5, and when you solve that as a decimal, you end up with 7.2. Okay, let's turn the page or flip it over to number 15. On these ones here, I want to just kind of talk about a couple things, not really solve all of them for you necessarily, but just help you remember that you're doing a word problem, so you want to be able to read it carefully and look at what they're asking you for. With this problem here, we can tell by the picture that we have Theorem 63, we have the side splitter theorem, okay, which is where you could set up to say this part over that part equals this part over that part. I think for the most part you're okay with that, and when we set it up, it looks like, you know, the short side x over the long side 2x plus 10 is going to equal the short side there 24 over the long side here 60. So now you're back to the same type of problem you had on the front page. What you need to keep in mind though, after you do this and you do the cross multiply and you do your distributive property, you will end up with a value of x when you're all done. X will equal some number. But remember, you're not done. This is just step number 1. You then have to use x for step number 2, which is the actual solution. How long is the path from the pond to the playground? Well, the pond is here, playground is there. When you find the x value, all you've done is say, I know what that is. What you haven't said is how far is it from here to here. So make sure you complete the problem by doing step 2 and plugging in your value of x and then solving for the whole thing. The pond to playground is actually x plus 2x plus 10. So you need to solve it by plugging that value of x into that to get your final solution. So don't forget that. On number 18, looking at another one here, same type of idea. You have this picture here, and we can see this is going to be one a lot like our corollary side splitter theorem. But instead of having just regular lines or letters, they make it look like a street. Same type of idea that you had before. So again, there's going to be 2 parts because you're going to have to find a missing piece. Okay, I don't know. The question says, how long is a section of First Street from Elm to Maple? Well, Elm to Maple is here, this whole segment. I don't know that. They give me this portion, but not this portion right here. So I have to find that portion out. But I also have to find the combined length as well. So knowing our corollary to the side splitter theorem, I could say that I don't know this and call that x, and make that over what I do know, 350, and then set that equal to this line over here. There's another street, second street, and I have the first part, 1650, over another part that I know, this one here, which is 300 feet. So now I have an equation set up, or worse set up. I could cross multiply. I could reduce first to make that work a little nicer for me. This will break down to a simple value of x. You'll be just fine there. You will get a regular number, not a fraction, not a decimal. You will get a value of x that will equal something, but remember, you're not done because the distance from on First Street from Elm to Maple is going to be the value of x, which is this little bit, plus the 350 that you already know from Oak to Maple. So this is part 2 of that question. Don't forget to do part 2. This is just part 1. And you'll solve part 1 for x, and remember to do part 2 when you're done with that. Okay, so I want to skip down to numbers 19, 20, and 21, which are very unusual perhaps from what we've done before. Again, I mentioned a few of these, I believe, on, I don't know, lesson 2 or 3, and I wasn't quite sure what they wanted to do with them. Talked to a couple people. It sounds like you may know some pieces of how to solve these, so I'm going to go ahead and work something out for you to show you how you do work solutions for these. Looking through your upcoming unit tests, I don't see a lot of this happening on the unit test, but it's going to be coming in future units as you go along, so you might as well take a look at it and see how does this work. All right, so what I'm going to do is I'm going to go ahead and zoom in on the problem, and I'll have to solve it somewhere else because there's just not space to work it out in this space right here. Looking at this one here, I have x minus 5, I have x minus 2, x minus 1, and 2x plus 1. That's my numbers I'm working with there. Zoom out, okay, and rewrite this here. I'm looking in this case at the corollary of the side splitter theorem. I can say, I'm going to, for now, I could say A over B equals C over D. And so when I rewrite this problem, here, I rewrite it as x minus 5, this is number 19, x minus 5 over x minus 2, I'm really good at mechanical pencils, huh? X minus 2 equals, the short side here, x minus 1 over 2x plus 1. All right, so when I cross multiply, I end up with some crazy looking things. All right, I'm going to rewrite this one here. When I cross multiply this, I end up with 2x plus 1 times x minus 5 equals x minus 1 times x minus 2. All right. Now, to solve this and get a value for x that it could be, I'm going to have to use distributive property. So I have to do this a little different. I'm going to go 2x times x is 2x squared. 2x times a minus 5 is a minus 10x. And I come down to the bottom. 1 times x is x, so plus x. And then 1 times a negative 5 is a negative 5 equals x times x is x squared. X times a negative 2 is a negative 2x. Negative 1 times x is a negative x. And negative 1 times negative 2 is a positive 2. So I end up with this long solution here. If I combine like terms, I have my x's. So I have 2x squared minus 9x minus 5 equals x squared minus 3x plus 2. Now, to get a solution for x, what I want to do is rewrite this equation so that I have everything equal to 0. That's my goal. So to do that, I'm going to move all of these things over to the other side by doing the opposite. I'm going to move them all over. So I have a plus x squared. I'm going to subtract x squared. So 2x squared minus a 1x squared leaves me with x squared. I have a negative 3x squared, so the opposite is to add 3. So I'll add 3x over here. So negative 9 plus a 3 gives me a minus 6x. And if I have plus 2, I'll do the opposite, which is subtract 2 from both sides. And negative 5 minus 2 more gives me a minus 7. And I'll set that equal to 0. Now this next step here is something I'm not sure what you remember from Math 1. It would have been probably a later unit that you did this in. But this is solving this expression. We want to go ahead and break it apart into 2 little parentheses sections. And I have to break it up into parts that'll work. The x squared can be broken apart into an x times an x, because x times x is x squared. Now I need to determine which 2 numbers can I multiply together to give me 7, And then when I add up the outsides and the insides with the FOIL method, if you remember that from algebra, from Math 1, leave me with a 6 in the middle. Well, my options for 7 is basically 7 times 1. So that's nice to know. My choice is pretty much 7 and a 1. Okay, no problem there. Well, now is it plus or minus? Minus or plus? Not sure there. I know that I have to have a minus 6 when I put it all back together if I was to multiply this out. So that means I want my 7 to be a minus, so that this becomes a minus 7x when I multiply the inside together. And when I multiply the outsides, x and 1, I want to be able to take 1 away, so that becomes a positive 1. So negative 7 plus 1 gives me a minus 6. So I know that that's going to work there. Now let's look at the numbers. Negative 7 times a plus 1 gives me a negative 7, so I'm good there. And I already know my x becomes x squared. So now what I have is x minus 7 times x plus 1 equals 0. My possible solutions for this equation are going to be x can equal whatever the opposite is. What would make it equal 0? X could equal 7. The opposite of minus 7 is plus 7. Or x could be a minus 1. Okay? X could be a negative 1 there, which seems a little strange, but it's kind of what we have. Let's look at my notes real quick here. X plus 6x, 2x. Yeah. And in our solutions, what's interesting is when you look at the textbook, the book only gives you one answer. They say x is going to be equal to 7. Okay? And that may be because we're adding things up, you can only have a positive solution. I'm not sure why. Honestly, I just don't know. I'm not sure why they say that. But that's how you work towards a solution set of x is 7, x is minus 1 there. I think that's right. I'm looking at my notes and I got a little different solution when I saw that before. I'm not sure where I changed things at. Say negative 9. Sorry, real quick. Plus there, minus 6. Okay, well that'll work. Let's look at number 20. One more of these real quick. With number 20, we're going to be using the Theorem 34 angle bisector, triangle angle bisector theorem. We can have that over that, or sorry, we could do either we want. This over that equals that over that. However you want to set it up, we can do this here. We can have the base and the base over the side and the side. So we're going to set up using the angle bisector theorem to create a proportion once again. So to set this proportion up, I went ahead and made mine 8x over 5x plus 3 equals 10x minus 2 over 7x. So I got that by looking at here. I did this one, 8x over that one, equal to this one over that one. Made sure I matched top, bottom, top, bottom. Again, you're going to multiply this out, cross multiply. 7x times 8x is a 56x squared, and that's going to equal 5x plus 3 times 10x minus 2. If I use my distributive property, I end up over here with a 50x squared. 5x times a negative 2 becomes a negative 10x. 3 times a 10x becomes a plus 30x. And then 3 times a negative 2 is a negative 6. All that equals 56x squared. So now I'm back to what I did before. Got to move things around so I end up with just a 0 on one side. I really don't want a negative value for my x squared, so I'm going to move everything over this way. Okay, I should combine that first of all, like terms. A negative 10x, positive 30x ends up with being a 20x, and that's a positive. So I'm going to subtract 50x from this side, 50x squared, and I end up with 6x squared. When I move a plus 20 over, I'm going to subtract 20x, so it's a minus 20x. When I move a minus 6 over, I'm going to do a plus 6 equals a plus 6, and that's going to be set equal to 0. Now with a little bit of Can I guess and check and see what I have? I know I have to look at, in this case, I can't just put x and x and be done with it, because 6 could be broken up into either 6 times 1, 3 times 2, and so I'm not sure which one to put there. So for now, I'm going to go ahead and just guess and say, let's go with a 3 and a 2, and just see if I make that 3 and 2, and then what values for this 6 could I use, or I can end up with a 20 back in the middle. Okay, so 6 can be a 6 and 1 again, or 2 and 3. I'm going to go to a 6 and a 1, and that's because I know that 6 times 3, if I look at my outsides, 6 times 3 is 18. I'm trying to get to 20, that's my goal. 6 times 3 is 18, so I would put a 1 here. So this 6 became 6 times 1, and this 6 became a 3 times 2. When I look at my outside, I have 18, and I know I want to get to 20, so this has to add up to my inside. 2 times 1 is 2, so 18 plus 2 gives me 20. Now, it's a negative 20, so they both need to be negative in order to combine together to give me a negative 20. Making them both negative is fine because negative 1 times a negative 6 equals still a positive 6. So I'm okay in that regard as well. So that's going to be equal to 0. So now when I look at my solution sets here, all right, I'm going to look at the x is going to be equal to the opposites. I could set it equal to 0 and solve, and that's really what they're wanting to do. But for now, I'm going to take and say instead of a negative, it's going to be a positive, and whatever that number is, that becomes my top number, and whatever this one is becomes my denominator. X equals 1/3. For this equation, x is going to equal positive, we have to have a positive solution, 6, top number, over this number, denominator, 2, which reduces down to 3. If you're not sure how that is so, let's take, for example, real quick, if you want to look, video's almost over, I promise, 3x minus 1, I just set it equal to 0, and I solve for x. So I would add 1, 3x equals 1, divide both sides by 3, and x equals 1/3. So that's the same solution I got there. I just kind of know a little math shortcut to say, well, if this is 3x minus 1, I make that positive, that becomes my numerator, that becomes my denominator. So if you wanted to solve each one and put it together to make it equal to 0, you could do the same thing, but it's a little bit of a shortcut there. So those are indeed my two solutions that are worked out there. You'll do the same thing for number 21. I will tell you right now for number 21, there are 2 solutions. So if you do number 21 and work it out, try it. You can do it. You get 2 solutions. You're in good shape there. All right, that's it. Have a great day.